boundary values were not defined in the requirements, how does the test analyst proceed? So at this point, I believe you're asking me about that, not the smallest recognizable difference, but rather about the where the behavior is supposed to change. Well, if those are not defined at all anywhere, it's going to be very difficult for you to do this, because in order to do the analysis, you have to be able to analyze the interaction between the factors. And if you don't know the point at which the variables, the equations that are being used to do the calculations are going to change, then you're going to have a great deal of difficulty with that analysis. So somehow or another, you've got to get some kind of insight into at what point do the variables, or excuse me, the values used, the equations used, change. And you know, if you can't get that information at all, there's a big bunch of factors and they interact, but we can't explain to you how they interact, or no one will tell you how they interact, and information is not available, then you're thrown back into the pairwise techniques where there's not an analyzable interaction, and you just have to apply the kind of pairwise techniques I discussed in the previous webinar. Go check out the recorded version of that pairwise technique webinar if you didn't catch it at the time, and that's pretty much what you're left with. Now, that's a really weak situation. I mean, the pairwise techniques are perfectly sufficient when there is no deliberate interaction. It's the only thing you're looking for is some sort of accidental interaction that might be there for some unpredictable reason. But when you actually have interaction that's being engineered into the system and people won't tell you what that interaction is, I have to kind of question the premise of testing at that point. It's like, well, what is this, 20 questions that you're supposed to guess what might be broken and guess at values? I mean, what's next? They're going to put a blindfold on you and hang up a piñata in the test lab and tell you to get the candy? So, if you can't get this information about where these behaviors are changing, I think you really need to start digging into this and say, well, why is that information not accessible? It's essential to design proper tests. Let's see, got a follow-on question from Chase here. Is there any correlation between the off value and the in or out value in terms of how close or far apart from each other they are? Okay, so to start with the off and on value, now the difference between the off and the on value is going to be that smallest recognizable difference that we were talking about before. So there is clearly a defined difference in terms of how far they are apart, at least in terms of the variable that pushes you from one domain to another. If we go back to the aerospace example, let me just show you. Yeah. If we look at the difference between 2, 3, and 4 in terms of time only, the difference is 1 microsecond, right? Because we said that was the smallest recognizable difference. If you look at the difference in terms of the YC value, that's arbitrary. The difference between 3 and 4, 2 and 4, and 2 and 3, completely arbitrary. I could have put them anywhere. Okay, so the difference there is driven by the factor that determines which domain you're in, and then the other factors are free to be pretty much anywhere on those. Now, in terms of the off value, the one just off the value, and the in value or the out value, now in this case, let's say we're talking about this is 2 and 4 with respect to 5 and 1. No, there is no rule that says that they have to be a particular distance away. So we could conceivably have put 5 right next to 4. Like, so 5 could have been at t equals 1.002 microseconds. Now, you could have done that, and you could have put the value of 1 at t equals 0.998 microseconds. But that would have that would have really been silly to have done that. Sorry, I misspoke. I said microseconds just a moment ago. I meant to say milliseconds. So 1 could have been a t equals 0.998 milliseconds, and 5 could have been a t equals 1.002 milliseconds. But as I was saying, that would have been really silly to have done that, because one of the other rules, general rules for test data, which is not covered in this technique, but is actually mentioned in Brian Merrick's book, Craft of Software Testing, I believe it's called. I always get that one mixed up with Jorgensen's book, The Software Testing and Craftsman Approach, but I believe that Merrick's book is A Craft of Software Testing. And in the Craft of Software Testing, Merrick comes out and says explicitly something, and I think it's fairly intuitive to most testers, which is that we should strive for the most diverse set of test data that we possibly can get. So there's no point in testing with values that are the same or close to the same over and over again. That diversity in our test data is good because it helps us stumble across the otherwise undiscoverable bug. I noticed that by testing with 5, one of the things that we could very easily find is that the programmer, when the programmer went to implement the code, actually created a third domain, a domain that we don't know about, that's out there at, say, t equals 2 milliseconds. Now, we wouldn't find that if we test very close to t equals 1 millisecond value, but if we test out further away from it, then we increase our odds of stumbling across that. So diversity in data is the rule I'm appealing to here. Again, this is not explicitly part of domain analysis technique, but it is a good general rule for testing. And for those of you who are of a technical mindset and would like to read another fairly advanced book on software testing, I can recommend Merrick's book. I wish I could find it just to confirm the title, but yeah, there it is, Craft of Software Testing with Brian Merrick. A good read, kind of a interesting approach to white box testing that's certainly worth taking a look at. Okay, so I'm impressed. Most of you were able to stick out that very dry material. I thought that I'd end up losing a lot of people along the way because it's is somewhat of a dry topic, but a number of you stayed engaged and had some good questions. That's great. To close this session, let me tell you a little bit more about the resources available through RBCS. We run these free webinar sessions once a month, so please check our website, www.rbcs-us.com, to sign up. If you would like a special webinar presentation for your company only of this webinar or on any other topic related to software testing, please contact us at info@rbcs-us.com or via our website. If you don't already receive our regular free newsletter, you can sign up at www.rbcs-us.com. By signing up, you'll get valuable discounts on consulting and training services, along with a regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. You can follow us on Twitter at twitter.com/RBCS and on Facebook at facebook.com/pages/RBCS-INC. Remember to check your email over the next couple of days, because you might be the lucky winner of a free e-learning course from RBCS. You are registered for a random drawing for such a course simply by attending this free event. Finally, check out our digital library. We have recordings of these webinars, podcasts, and videos. You can also subscribe to our podcasts via iTunes by entering RBCS Podcast into the search string. And you see the videos and recorded webinars by subscribing to the RBCS channel on YouTube. We offer these free resources as a service to the software testing community because at RBCS we are a not-just-for-profit company. This concludes the webinar. I'd like to thank everyone for joining us today. Look forward to seeing you on subsequent webinars.